Hello, Algebra 2 folks, and welcome to Graphing Absolute Value Equations. We're finally expanding beyond lines and getting into more Algebra 2 stuff. So the key idea today that you should really have in the back of your mind as we're doing this is that the word value begins with a V. You need your notes, a pencil, and possibly a calculator. So the learning objective is I can graph an absolute value function using a table. We're going to start with example number 1. I want you to graph y equals the absolute value of x. This is called the parent function. The parent function, there's a parent function for every single type of graph we graph this year. It's like the basic graph we can graph. Then all other graphs come from that parent function. So let's start with the parent. So what we do is we take what's inside the absolute value, which is the x, and we set it equal to 0. Okay? And what this gives us is the x value of our vertex. And the vertex always goes in the middle of the graph. So it's a 0. Now when you plug it back in and find y. Well, the absolute value of 0 is 0. Okay? So the vertex of this graph is 0, 0. Okay? Now we're going to do some points below 0 and above 0. We have to find the vertex first. If we don't find the vertex first, then we won't have the graph we need. So now I'm going to do -2 and -1 and 1 and 2. So the absolute value of -2 is +2. Absolute value, remember, means distance from 0. So it's always going to be positive. The absolute value of -1 is +1. The absolute value of 1 is +1. The absolute value of 2 is +2. So my graph will be -2, 2, -1, 1, 1, 1, and 2, 2. And remember the key idea I just said at the beginning of the video? That value begins with V. All absolute value equations graph to form a V. And if you don't get a V, then you are not graphing these graphs correctly. Excuse me. So the vertex is 0, 0. Sorry again. Now let's look at the domain and the range. Okay, one of the key features we learned a couple of days ago. If I were to fold over the right side, I encounter an arrow. If I fold over the left side, I encounter an arrow. So it would be -infinity to infinity. The range, if I fold up the bottom, it hits 0. And if I fold up the top down, it's going to encounter 2 arrows. So it's 0 to infinity. All right, now where is the graph increasing? So the graph is increasing here. Now what's that interval? Okay, remember it's the x values. So the x value that it starts to increase at is 0, and it continues to increase to +infinity. Where is the graph decreasing? The graph is decreasing on this left side it's decreasing from negative infinity, because this keeps going forever, all the way to 0. And remember, these are x values, okay? We don't use y values, we use x values when we're talking about increasing. And then the max or the min, in this case, it would be a minimum because there's a low point. So we would circle minimum, and that minimum value would be 0, 0. Okay? All right. Now let's do another one. Okay, example number 2 says y equals 2x plus 1, the absolute value of all of that, minus 4. So just like the parent function, we take what's inside the absolute value, we set it equal to 0, and we solve for x. So the x value of our vertex is 1/2, negative 1/2. Now, we plug that back in there, and it's going to give us a 0, because that's where it's equal to 0. The absolute value of 0 is 0, and 0 minus 4 is negative 4. Okay, now I need to do some values less than negative 1/2, which would be negative 1, negative 2, and greater than negative 1/2, which would be 0 and 1. So I am going to plug in negative 2, or positive 2 times negative 2 plus 1. That's negative 4 plus 1. That's negative 3. Absolute value of negative 3 is 3. And then I'm going to subtract the 4. So I have to keep bringing down the 4. That would be negative 1. All right, let's do negative 1. So 2 times negative 1 plus 1, absolute value of that minus 4. Negative 2 plus 1, absolute value of that would be, negative 2 plus 1 is negative 1. The absolute value of that is 1, and then minus the 4 would be negative 3. Okay, now we plug in the 0. 2 times 0 is 0. 0 plus 1 is 1. The absolute value of 1 is 1. And 1 minus 4 is negative 3. Now plug a 1 in there. 1 times 2 is 2. 2 plus 1 is 3. The absolute value of 3 is 3. And 3 minus 4 is negative 1. So the vertex is negative 1/2, negative 4. Now I'm going to plot those points. Negative 1, negative 3, 0, negative 3, 1, negative 1, and negative 2, negative 1. And look, I still have a V. All right, now let's look at the domain. Close over the two sides, left and right, and you will run into arrows. So that would be negative infinity to positive infinity. The range would be negative 4 to positive infinity. Increasing would be this right side over here, and that begins at negative 1/2 and goes all the way to positive infinity. And then the decreasing is on the left side, and that goes from negative infinity to negative 1/2. And then the minimum or maximum value, in this case we have a minimum. The minimum is negative 1/2, 4. Negative 4. Negative 1/2, negative 4. All right. We will do one more. This time we have a negative out in front of our absolute value, so we have to take that into consideration. So the first thing we need to do is take what's inside and set it equal to 0. X is going to be 2. Put the vertex in the middle of our table. If I plug 2 back up in here, I'm going to get 0. The absolute value of 0 is 0. 0 times negative 1 is 0. Plus 3 is 3. So our vertex is 2, 3. All right, now we're going to find values that are less than the 2 and greater than the 2. So 0, we're going to plug 0 into our equation here. 0 minus 2 is negative 2. Bring down the negative, bring down the 3. Absolute value of negative 2 is a positive 2. Bring down the negative, and negative 2 plus 3 is 1. Now you have to really be careful because lots of people want to distribute this negative. Okay, these are absolute value signs, not parentheses. We cannot distribute the negative when we have absolute value signs. You have to do what's inside the grouping symbols, then multiplication. Okay, so make sure you remember to do that. That's where a lot of people make a mistake. So the absolute value of 1 minus 2 plus 3, 1 minus 2 is negative 1. The absolute value of negative 1 is 1. Bring down the negative. Negative 1 plus 2 is negative 1 plus 3 is 2. Okay, now let's do 3. 3 minus 2. 3 minus 2 is 1. The absolute value of 1 is 1. And negative 1, bring the negative down. Negative 1 plus 3 is 2. And then negative absolute value of 4 minus 2 plus 3 is absolute value of 2, which is 2. Bring down the negative. Add the 3, and you will get 1. So we should graph this, and it should look like a V. If it doesn't look like a V, then we did something wrong. Oh, it still looks like a V, but guess what kind of V it is? It's upside down. Okay, so it's an upside down V. The domain is still going to be negative infinity to infinity. The range now is if I fold the top down, it goes to 3. But when I fold the bottom down, you encounter the arrow. So the range is negative infinity to 3. Okay. This time we have a maximum value. That maximum value happens at 2, 3. Okay. The increasing values and the decreasing values, remember, they're your x values. But this time the increasing is on the left. And so that would be negative infinity all the way to the x value of 2. And then the decreasing would start at that 2 and go all the way to positive infinity. All right, those are my 3 examples. I just want to do a quick summary. I would write this down in your notes as well. So absolute value graphs are V-shaped. If you don't get a V, you didn't graph the absolute value right. You find the vertex by setting what's inside the absolute value expression equaling to 0. You complete the table, making sure you do values on both sides of your vertex, plot the points, and then if you don't have the V shape, then you did something wrong because we have a giant V for value. All right, that's all I have for you today. Have a fabulous day, and we'll see you tomorrow.